Hey everybody, welcome in. What can chess teach us about AI coding? That's an interesting, weird kind of question to ask. It's about scenario analysis. So we're looking at a tool here called lightchess.org, and I'm going to show you something. When you pull this in and you move this piece right here, it's going to tell us, oh, well, that's Anderson's opening. Let's do that one. And then it's going to write back and say, well, that's another move. And I'll pull that together, and I pull that one down here. And we are watching as a system live is analyzing the results and telling us whether I'm playing chess correctly or not. So let's see here. Here we go. Pull here. Pull that one here. Oh, I'll take that one. And just like that, we've got an analysis system that's downloading every move that we made. It's calculating the best possible moves on the next thing. This is scenario analysis. And this is what they did with IBM Watson. They trained it to be able to beat Gary Kasparov, which he did, which was kind of interesting. There's the next best move, buddy. You should do that one. Okay. Well, let's go back to the board and let's start all over again. We're going to pull up the board. I'll show y'all how this relates to AI coding here in just a second. Let's see if I can do play, learn, practice. Let's see. Go back to the board here, analysis board. And this time around, I'm going to pick this little button here. I'm going to click on the board editor, and I'm going to show you how I code using AI. Here we go. This is Windsurf, and I'm using a technique just like what I'm describing on this chessboard. I'm using right here to train an AI to do something it's not built to do right now. Kind of interesting. So I'll pull that off the screen, and I'm going to show you how it works. The first thing you've got to do is write documentation for what you want to do. That's the first move. Write documentation for what you want to do. In the second move, you ask, and I'll pull this one over here, the system to write code that does exactly that. And in the third move, you ask it to check to make sure that what is going on between the documentation and the code is actually correct. You give it iterative steps to make sure that what you documented is exactly what it built. And it's rotating and repeating until it finishes. At that point, you write version 2 and say, I want to make some small and tiny changes that would improve this system just a little bit. And then you rerun to make sure that you start pulling that code all the way across so you got the version 2. Then you make a copy of the documents again. You say, write me version 3. And you're asking AI, keep working on this software until it's just a little bit better, and then architect that code, and then go and fix any mistakes, anything you're doing. This technique just moved us from version 1 to version 3 in 90 minutes, a process that used to take a human team 3 months. 3 months. And that's exactly how we build Rhea. Right here, event planning. This is something that a user might say into the microphone. Hey, for the annual conference, book the venue by the end of the week, send out save the date emails, finalize the speaker list, arrange catering, prepare presentation materials, and don't forget to set up the registration page. Those are all things that I might want to put into a task system so that an AI could break that up and then tell me how hard it would be to complete each one of those things. Maybe I just want to put it in my task list because I know I thought of it. Well, problem is traditional AI out of Silicon Valley can't do that. They don't have metacognition. They don't have an ability to think about the problem. They can't do something called thinking about thinking. And so when it tries to break that up, it gets the wrong answer routinely. And because it routinely gets the wrong answer, we have to engineer our own custom system in which Rhea is able to break this up on her own because she is not just one AI, she's a bunch of them working as a team. That metacognitive process allows her to break it up. The problem is she doesn't know exactly how to get to the target. If this is what the user wants, this is the target, what we call the ground truth. These are the 6 things she needs to get to. And we could train her over and over and over again using that chess thing that I showed you to get from this sentence that a human would say to the 6 tasks that I actually want. It's an iterative process. We call this declarative coding. We're not being imperative. I'm not saying do this, do this, do this, do this. I'm not using engineering principles to complete the task. Instead, I'm simply saying this is what I want, this is what I have, and here's a list of things I don't want. And we declare what we need, and then she rotates around the problem until she solves it. And you can see right here, version 1 of the documentation for Rhea's pod system, 2-stage pod, overview of responsibilities, the pod facilitator, a proposed refactoring guideline, key interfaces that she needs to build for herself, and a versioning standard operating procedure so that by the time she gets to the end of version 1, she knows how to build version 2. We then build version 1 with all the code that's necessary to manage her, use on a back end to keep her facilitating conversation and performing metacognition, and even a pod structure to keep it all together. That's version 1. At which point we write the version 2 docs and say, you know what? Let's do some enhancements. Let's make her smarter. She's not there yet. And then we start writing code for version 2, which I haven't even started on yet because I'm still working through the docs. But here she is. She's going to copy all that code over. And Rhea is actually built into Windsurf for us. We've built it to do things that it's not meant to do. And so we're the only team in the world that has Rhea inside of Windsurf to be able to cook code for us. And here she's stepping through it now. Those of you who use Windsurf are not going to see. There's nothing that you can see that will show that it's a smarter system, but it is a smarter system because of how we set it up. And so she's working through the problem right now, building out and making changes to version 2. Software engineering will change forever. And it starts with understanding the techniques that you do to complete code way faster than you ever could before. And it also starts with understanding that we are now in a world in which we declare to AI what we want and ask it to continue solutioning the problem until it arrives at a conclusion that we could agree with. That is completely different than the world in which we start with a little piece of code and we test and we test and we take months. No. We take days, maybe even hours to be able to complete everything we need to do. Here we go. She's already working on breaking it up into template configurations because she decided that that was a better way to do it. It keeps it smaller and more nimble. And so we end up with service prompts for task podding, metapod responsibilities. She's coming up with this all on her own. A fascinating prospect of AI. In any case, if you have any questions, let me know down below. Start using this chess methodology for yourself. Write a version 1 of documentation. Write the version 1 in code. Write version 2 of documentation, which is an improvement. And then write version 2 of the code and keep going until you climb the ladder to something amazing. Very few AI systems in the world can do that, but you can get started in Windsurf. And if you're a customer of ours, then you'll know that we're building software faster than almost anybody you can work with because we've got a custom system for doing just that. Thanks.